So guys, this is question number 40 from the practice final from fall 2000 that was posted today. So let's take a look at what's going on here. So we want to build the 98% confidence interval for a proportion here. So the confidence interval for a proportion is given by p hat plus minus z alpha over 2 times p hat times 1 minus p hat, all divided by n. And we want our 98% confidence interval, or the margin of error of our confidence interval, to be within 0.02. Okay, so this guy is our margin of error. Okay, so to compute the required sample size, and what we're looking for here is how big does n have to be in order to make sure that our margin of error stays within 0.02. So for a 98% confidence interval, z alpha over 2 will be 2.33, and we want to look for n. The formula for this guy is n is equal to z alpha over 2. Actually, let me go grab it. Let me go grab a screenshot of it. So this is the formula of interest when I rearrange the margin of error and isolate n on the left hand side. So z alpha over 2 is, z alpha here is 2%, so it'll be z sub 0.01, which is 2.33. Or, to be more accurate, it's actually equal to 2.326, but 2.33 is fine. I'm going to square that. And the margin of error in the denominator, that's the desired margin of error in our question, that's 0.002. The problem in this question is p hat is not given. There's nothing here that tells us, how many n people we've sampled. So whenever p hat is missing, guys, here's a rule of thumb. Just always use 0.5. Okay. There's a mathematical reason behind it, but at this point in time, the day before the exam, just use it. And you're gonna see that if you compute this guy, because 0.5 times 0.5 is half times of 5, algebraically, it ends up being 2.326 squared all over 0.02 squared times a quarter. If you look at the answer here, you see the 4 there in the bottom. That's, algebraically the same thing as this guy. And you'll see that that's going to be equal to 3,382.